8.5, adding and subtracting rational expressions. Just like with fractions, we're going to need to find common denominators. All right, when you're adding and subtracting rational expressions, remember they're really complex fractions that you're going to be using all those rules for fractions in order to simplify. So remember when we added 1/2 plus 2/3, we had to have common denominator. Okay, so that would have been 6. So we had to change both of these to 6 before we could put them together. That would have made 3/6 and 4/6, which would have made 7/6. Okay, so we're going to have that same situation going on when we're adding or subtracting rational expressions. So first thing you're going to want to do is find your LCD. You're going to make those equivalent fractions just like we did here. You're going to add and subtract the numerators, and then you're going to keep that denominator. Okay? So let's get started with this, a less problematic one. All right, so we're looking at the denominators. We're adding and subtracting, or subtracting. We have 6y on the bottom and 14x squared y squared. That has to be the same exact thing. So we have to find the lowest common denominator between the two. Well, if we did 14 times 2, that's 28. 6 won't go into 28. 14 times 3 is going to be 42, and 6 will go into 42. So we know 42 has to be it. Okay, 42, and we have a y here, and we have y squared, so it has to be at least y squared, and we have to have an x squared also. So that is going to be your LCD. Okay, so we have to have everything. We have a y in this, but we don't have x squares and the y squares, so that's why it has to be 42 x squared y squared. Then you look and say, okay, what do I need to do to 6y to make it into 42 x squared y squared? Well, I need to multiply by 7, and I need another y, and I need x squared. Okay, that's what I'm going to have to multiply to the 5x squared in order to get the common denominator. Over here, what do I need to do to make this 14x squared y squared into 42x squared y squared? Well, I have all my variables. That's not the problem, but I do need to multiply the top by 3. Okay? So when I do this, I'm going to have 7 times 5, which is 35. X squared times x squared is x to the 4th, and then y. Okay, so you're going to be using rules for your exponents, your fractions, a lot of the stuff you've learned, you're going to use all those rules. And that's going to be all over your 42x squared y squared. And here you're going to be multiplying by 9 times 3, which makes the 27. All of that will be all over top of your LCD, which is 42x squared y squared. So that's what this is, this added to this. Now, if there was something in common between all of these numbers, big numbers, you would take that out, but there's nothing in common between 35, 27, and 42. There's no letters in common, so there's nothing that you can take out or simplify. So this is our answer. Okay? Again, if this had been, say, 36 instead of 35, then you could have took 3 out of everything. Okay? But just watch those when you finish. Just like I've told you several times this year, you simplify, then you finish, then you simplify again. You just keep checking all the way through to make sure it's completely done. Okay, now let's go to another problem where we're actually going to be factoring. All right, so we have this rational expression multiplied to this. Now, in order to find the LCD, you need to factor. Anytime you see GCFs, factoring, anything like that needs to be simplified, you have to do it. So we're going to take a GCF of this bottom here, and that would be x. That leaves us with x plus 3. Okay, so that's going to replace that. this becomes x plus 3, x plus 3. Okay? It's the only way you're going to be able to see the LCD. If you don't split it up, you will have no idea. Now, this one has 2 x plus 3's, and this one only has 1. This one has also an x. So the LCD is going to be the smallest that you can get between the two of them. Okay? So we have to have these two, and then you look over here and see I have to have also an x. So the LCD has to be x plus 3, x plus 3, and an x in the front. Okay? It has to be the lowest that they both share in the combination. So then you look at just this fraction over here, this rational expression over here. I have this part and this part. What else do I need? I need an x plus 3, so that's what I'm going to multiply the top by. Okay? Over here, I have the 2x plus 3's. What else do I need? I need an x, so I'm going to multiply the top over here by just the x. The LCD is going to be the whole thing, x times x plus 3, x plus 3. Okay, that's all across the bottom. That will be your bottom in your answer. Okay? Not parts, but all of it. So then you can just multiply the x plus 3 times the 4, which I have set up here, and you get 4x plus 3 all over that LCD. Over here, you're going to be multiplying the x to this. Remember, this is a quantity, so you have to multiply the x to the negative 2 and the x to the x, and you get x times x minus 2, which is all over top of your LCD. Now you want to put these together. When we were multiplying and dividing, we left them separate and we didn't distribute through. You're going to need to put these together. You can't mark things out, okay? Because we're adding and subtracting, you cannot mark and simplify until the very, very last step. So make yourself a note. Cannot cross out until last step. This is only true when you're adding and subtracting. Okay. All right. So we multiply this through, we get 4x plus 12, and we multiply this through, and we get x squared minus 2x. Then you clean this stuff up on the numerator. You have to clean it up, put it in order, and you get x squared plus 2x plus 12 when you combine like terms. This does not factor. Okay. So just if it does not factor into nice, pretty little factors like this, leave it alone, and then put that all over top of your LCD. This is the final answer. There was nothing else we could do. So you see, if you would have started canceling this stuff out, it would not have made the right answer. Okay? So when you're adding and subtracting, you cannot start canceling stuff out until the very last step. Okay? It's not multiplication and division. Remember, multiplication and division is where we were able to cross reduce. All right? We cannot do that because we're adding. Okay? All right, so let's go. I think I've got another problem. Yes. All right. Complex fractions. Students in the past have given this wonderful little nicknames. They're not difficult at all. They look horrible because it's a fraction divided by another fraction with stuff being divided in between. Really, it's not that difficult. These are just huge division problems, and as we've already learned, you have to change division to multiplication and flip that second fraction. So if you read this to me, you would say x squared divided by 9x squared minus 4y squared, all divided by x cubed divided by 2y minus 3x. Well, this bottom fraction is what's dividing on the top, okay? So you just rewrite it in pieces. Here's the first piece divided by the bottom piece. Now it looks a little bit better. Then you know that we can't divide fractions, so we have to change that to multiplication, and we have to flip the second rational expression or fraction, okay? So this becomes this. Now it's multiplication and division. which means we can simplify and cross-reduce. Versus the adding and subtracting, you can't do that till the very last step. Alright, so I'm going to factor 9x squared minus 4y squared. This happens to be a difference of squares, which factors out to be this. Okay? Now, notice right here I have 2y minus 3x. And this is only a problem because it's subtraction right here. Okay? Had it been addition, it's not a big deal. But because it is subtraction, that minus 3x, that negative 3x, makes it special. You have to be very careful with this. You can't just turn it around to make it work for you. You have to, because it's subtraction, take out a negative 1, which will flip it around and make the 3x positive and the 2y negative. Okay? Whereas before it was the other way around. The 3x was negative and the 2y was positive. So when you want to flip it around, if there's a minus in the middle and you want to flip it around, have to take out a negative 1. If there's a plus right there, you don't. You can just turn it around because addition is commutative, whereas subtraction is not. Alright, so now I did that because I saw that I had this down here and I wanted to get rid of one of these to make it simpler. So I can now cross out the factors that are the same and cross reduce this way, and that will leave me with an x down here and negative 1 up there, and then this right here, which becomes negative 1 all over x times 3x minus 2y. Okay? Complex fractions are not difficult. I think you'll like them. Now, you may have complex fractions where there is addition and subtraction involved first. If that's the case, you have to clean that up before you can start this process. So in other words, if I had 1x plus this on the bottom, you may have those. You have to clean this up, the adding and subtracting, which we just did a few seconds ago, where you have common denominators. Clean that up, then rewrite it, then change the multiplication, and then go on. So it's an extra step or two, okay? So watch that. If you have that, that has to be treated first before you can do anything, okay? All right. And I think that's all of my examples, yes. So if you have any questions, come in and work with me. These will take a few steps. It'll take a little bit of work, a little bit of paper, but it's okay. They're not that difficult. And with practicing, you'll see this will help you even remember some of your factoring. But yeah, come in and see me if you're running into problems. See you in class.